Hello all, I'm Professor Archana Brusoli, welcome to the System Professor Computer. In this video, we are going to discuss the disk scheduling algorithms part 2. In part 1, we already discussed about the disk scheduling. What is disk scheduling? What are the algorithms? And some of the algorithms also we have discussed. So remaining algorithms we'll discuss in this video. Okay. So as we know, there are the four disk scheduling algorithms. First come first serve, that is FCFS, then SSTF, that is the shortest seek time first, then scan algorithm, which is also called as the elevator algorithm, and the last one is the C-scan, that can also be called as a circular scan algorithm. Out of these four algorithms, the first two algorithms we have seen in the part one of the disk scheduling video. So in this video, we see the scan algorithm and C-scan algorithm. So let's continue with the scan algorithm here. So in the scan algorithm, the disk arm moves in a particular direction. For example, the initial head position is suppose 50, so it may move from the 50 towards the 100, or it may move from 50 towards the 0. It depends on the instructions given by the user. So in scan algorithm, disk arm moves in a particular direction and services the request coming in its path. Whenever it is moving from one direction to other, the whatever the requests are coming, it services those requests coming in its path, and after reaching the end of the disk, it reverses its direction and again services the request arriving in its path. So this algorithm works as an elevator. The function is same as elevator, so we can call this algorithm as elevator, and hence is also known as elevator algorithm. As a result, the requests at the mid-range are serviced more here. As a result of this working of the scan algorithm, the requests which are coming at the mid-range of the particular path are serviced more, and those arriving behind this arm will have to wait more time. Okay, so here is one example. You can see one example of the scan algorithm. You can see here, suppose the request to be addressed are, so this is the queue of requests starting from 82, 170, 43 up to 190, and the read write head position or arm initial head position is given is at 50, and it is also given that this arm should move towards the largest value, so it will move from 50 to 199. In some cases, if it is given that it should move towards the smallest value, it will go in opposite direction. Okay, as it is mentioned here in this example, towards the largest value, so it is moving from 50 to the next request, that is the 82. Then it will, so accordingly it will go to the 170, then the next request is 170, then 190, and then 199, and then it reverses its direction in the opposite end. And while it reversing its direction in the opposite end, so whatever the request coming in its path while reversing to the opposite end, it is serving those requests in between. Okay, for example, the request 43, 24, and 16, it is serving. Okay, so therefore the total overhead movement over here for this example, or total distance covered by the disk arm, is calculated as 199 minus 50. So we are taking the largest value minus the initial head position plus the largest value minus the smallest head position. So whatever the addition of these two, you will get the total overhead movement, that is a 332 for this particular example. Let's see one more example of the scan algorithm here. You can see the queue of IO request is given here. Head position is starting at 53. Now in this example, you can see that we are not moving to the largest value, we are moving to the smallest value. Initial head position is 53. So instead of moving to the largest value, we are moving to the value 0. So depends on whatever your instructions you are giving to this algorithm. You want to move to the largest value or to the smallest value from the initial head position. So in previous example, we have seen that we were moving to the largest value. In this example, we are saying that we are moving to the smallest value from the initial head position. Okay, so we are moving from 53 to 37, then 14, then 0, and then once it is reaching to the end, that is 0 is the one end of the disk, then after that it will reverses its direction and it will reach to the opposite end, and while it will reach to the opposite end, it will service the request whichever the requests are coming in between. You can see like this. So this illustration shows the total head movement of the 208 cylinders. So while you are implementing this particular example, so what will be the input required for not example where you are implementing this particular algorithm, scan algorithm or any of the disk scheduling algorithm, what is the input required or output is expected? So you can see here input required is the request sequence, IO request sequence. Okay, so sequence is given here. Then the initial head position you need to move, you need to specify what is the initial head position. And the third thing is you need to also specify the direction. In which direction you want to move the arm first, whether you want to move the arm to the left or to the right. Okay, so it means to the highest position or to the lowest position. So that direction also you need to specify. So that is the input. Based on this input, it will generate the output. What will be the output? Total number of seek operations, that is a head movement it will give you. That is the total number of head movement, total number of head movement, and the seek sequence, in which sequence the particular IO requests are serviced or IO pages are visited. So that seek sequence also you need to print in the output. So that is the input and output for scan algorithm. While you are implementing, you need to specify this input and expect this particular output. Now we'll see the advantages of scan algorithm, advantages and disadvantages. Okay. So first of all, advantages. This algorithm is simple and easy to understand. Scan algorithm has no starvation because it is servicing the request as and when it is going from the one end to other end, whichever the requests are coming in between, it is servicing those requests. So there will be no starvation of the request. This algorithm is better than FCFS disk scheduling algorithm, yes, because the disk arm movement or total overhead movement is reduced over here in the scan algorithm. Next one is the disadvantages of the scan algorithm. It is a more complex algorithm as compared to implement if we compare it to the FCFS or other algorithms. This algorithm is not fair because it causes a long waiting time for the cylinder just visited by the head. As it is moving in this particular direction, so whatever the cylinder is already visited, if the request come to that for that particular cylinder after it has visited that particular cylinder, so it is moving ahead, so it will not go back again, so it will reach to the other end and then only again go back. So in that case, that particular IO request has a long waiting time. It causes the head, the another one, it causes the head to move till the end of the disk. In this way, the request arriving ahead of the arm position, requests which are arriving ahead of the arm position will get immediate service. But some other requests that arrive behind the arm position will have to wait for the request to complete for long time. So these are some of the disadvantages of the scan algorithm. The next algorithm we are going to cover in this video, that is a C-scan. C-scan stands for the circular scan algorithm. In the scan algorithm, the disk arm again scans the path that has been scanned after reversing its direction. So it may be possible that too many requests are waiting on at the other end, or the maybe zero or few requests pending at the scanned area. So this situation can be avoided here into the circular scan algorithm, in which the disk arm, instead of reversing its direction, goes to the other end of the disk and starts servicing the request from there. So while it is reversing, while it is going to the other end, that time it is not attending any of the requests. It just travels to that particular request to the other end of the other end, and then only it again starts the request. So the disk arm moves in a circular fashion, and this algorithm is also similar to the scan algorithm, hence it is known as a C-scan, that is a circular scan algorithm. Provides a more uniform wait time than scan. The head moves from one end of the disk to the other, servicing requests as it goes. When it reaches the other end, however, it immediately returns to the beginning of the disk. Whenever it reaches to the other end, means suppose the initial head position is 50, so it will reach from 50 to the 0, suppose. So from 0, it will immediately go to the highest position, suppose 199. And while it is going to the other direction, it will not service any of the requests. Okay, it will immediately return to the beginning of the disk or ending of the disk without servicing any request on the round trip. It treats the cylinder as a circular disk that wraps around from the last cylinder to the first one. So you can see here in the example that suppose the request to the address are given as the sequence of requests and the read write head arm is at position 50, and suppose it is also given that the disk arm should move towards the largest value. It is given that disk arm should move towards the largest value. Okay, that is the direction. So it will move from 50 to 82, then 82 to 142, then 170, 190, and 190. So it has reached to the one end of the disk. Now it will immediately go to the other end of the disk without servicing any request. So you can see here that it is going from 199 to 0 without servicing any of the requests. As the requests are coming in its path, but it is not servicing those requests. And then from here, once it reaches to the 0, then from here it again starts servicing the request, that is the 16, then 24, then 43, like this. Okay. So the total, so this is the circular. So it is going circular like this. So that's why the name is a circular scan. So the total head movement or the overhead movement in this particular example will be calculated as given below, and the total is 391. Advantages of the C-scan algorithm. Here are some of the advantages. It provides more uniform wait time compared to the scan for the processes which are coming behind the disk arm. Okay. So this is the example. One more example of this. You can see the queue of request is given, head start position is given, direction is going from 53 to the largest value, and then largest value, it is going to the other end of the disk without servicing any request. So that is a circular, and it is again start servicing the request like this. Okay. So this is the second example of that. So in this way, we have seen all the disk scheduling algorithms, right from FCFS, SSTF, C-scan, and C-scan. In this video, we have seen only the scan algorithm and C-scan. So we'll look various disk scheduling methods to optimize the secondary storage access over here, to optimize the request, or to check which particular algorithm gives the minimum overhead total time. So that are all these things we have seen. So you can implement all these scheduling algorithms. So thank you for patient listening.